Welcome to Tech AI, where we decode the art of prompting for large language models. In this series, we'll explore 5 powerful categories that elevate your AI outputs: core techniques for foundational strategies, knowledge and reasoning to enrich accuracy and logic, advanced structures for multi-step and parallel flows, adaptive and programmatic approaches that bring code and automation into prompts, and multimodal and hybrid techniques to blend text, visuals, and action. Let's dive into the future of intelligent instruction design. Let's dive in each category in detail now. Core techniques. Zero-shot prompting are directly tasking an LLM without prior examples. Few-shot prompting, giving examples to guide the LLM's response. Chain-of-thought prompting, encouraging step-by-step reasoning. Meta-prompting, prompts about how to prompt. Self-consistency, sampling multiple reasoning paths for better accuracy. Zero-shot prompting is as raw as it gets. You give the model a task, no context, no examples, just the goal. It tests the model's intuition and generalization capabilities. Let's look at an example. Prompt: write a tweet announcing the launch of a new AI-powered note-taking app. With no prior samples, the model draws purely on its training to craft something original. The result? Quick, unassisted creativity. Ideal for rapid ideation, one-off tasks, or when examples are unavailable. Few-shot prompting adds guidance. You show the model a few examples of what you want, then ask it to follow the pattern. It helps the model align with your style, format, or tone, making outputs more predictable. Let's see how it works. Prompt: here are 2 tweets announcing AI apps. Now write one for our new note-taking tool. The model learns from the samples and continues with a similar structure. That's the power of context. Directing the model without coding, just by showing the way. Chain-of-thought prompting unlocks the model's reasoning engine. Instead of jumping to a final answer, we ask it to think through each step first. It's how we turn AI into a problem solver, one thought at a time. Let's walk through an example. Prompt: if a train leaves at 3 p.m. and travels 240 kilometers at 60 kilometers per hour, when will it arrive? The model calculates speed, distance, and time, explaining each step before reaching the answer. Whether it's math, logic, or decision-making, chain-of-thought brings transparency to AI thinking. Meta-prompting flips the script. It's prompting about prompting. Instead of giving a task, we ask the model to improve how the task is framed. It's like handing the AI a megaphone and saying, "Guide yourself." Let's try an example. Prompt: improve this prompt. Write a report on AI trends. The model refines it to something like, summarize the top 3 emerging AI trends from recent publications, including real-world applications. More clarity, more specificity. Meta-prompting helps engineers shape better instructions without writing code. Self-consistency takes prompting one step deeper by asking the model not just once, but multiple times. Each attempt explores a different reasoning path. Then, we select the answer that shows up most consistently across those paths. It's like polling the model's own logic. Let's check out an example. Prompt: find the smallest 3-digit number divisible by 7. The model tries several methods: division, iteration, even rounding heuristics. Then we pick the result that appears most often. It's powerful for improving accuracy in math, logic, and decision-making under uncertainty. Self-consistency takes prompting one step deeper by asking the model not just once, but multiple times. Each attempt explores a different reasoning path. Then, we select the answer that shows up most consistently across those paths. It's like polling the model's own logic. Let's check out an example. Prompt: find the smallest 3-digit number divisible by 7. The model tries several methods: division, iteration, even rounding heuristics. Then we pick the result that appears most often. It's powerful for improving accuracy in math, logic, and decision-making under uncertainty. Knowledge and reasoning techniques take prompting to the next level. First up, generate knowledge prompting. Ask the model for key facts before jumping into tasks like writing an article. Think of it as preloading the brain with info. Next, tool use reasoning. When the task calls for precision, the model taps into external tools, like calculators or web plugins, to fetch reliable answers. Finally, Retrieval-Augmented Generation, or RAG. The model searches documents, reads them, and creates outputs using that extra context. Together, these techniques build smarter workflows with clearer logic and deeper knowledge. Generate knowledge prompting starts by asking the model for key facts before diving into any task. It's like warming up the engine with relevant knowledge. For example, prompt, list 5 key features of quantum computing in simple terms. The model responds with simplified highlights, like superposition, entanglement, qubits, error correction, and speed advantage. With this foundation in place, we move to the main task. Now write a blog intro explaining how quantum computing will impact cybersecurity. The earlier facts guide the tone, depth, and clarity. This technique improves coherence and accuracy, especially for complex or unfamiliar topics. Tool use reasoning lets AI tap into external resources to improve accuracy and depth. Instead of relying only on internal knowledge, the model calls tools like calculators, web plugins, or APIs. Think of it as giving AI a smart toolbox. Let's walk through a timeline. Step 1. Prompt. What's the inflation-adjusted cost of a product from $2,000 worth $500 today? Step 2. The model invokes a plugin, grabs CPI data from a trusted source. Step 3. It calculates and responds, roughly $850 in today's terms. Using tools brings real-time data, verified logic, and domain expertise, making AI more capable and reliable. Retrieval-Augmented Generation, RAG, boosts model intelligence by pulling in external knowledge. Instead of relying only on what it was trained on, the model searches relevant documents in real time. Think of it as giving the AI access to a live library. Here's how it works. Prompt. Summarize the latest research on quantum encryption. The model searches a curated knowledge base or the web, finds useful sources, reads through them, and then generates the response based on that fresh context. This makes RAG perfect for tasks needing up-to-date info, citations, or factual depth. It's how we bridge static models with dynamic intelligence. Let's cover more in the next video. Please do send us your comments.